Hey there! I guess you're having a lot of fun because you're back, okay? Here's another application of a hyperbola. There's two microphones, and the microphone one, oh sorry about this, I didn't mean to do that. Microphone one is here. I really typed the microphone, right? Isn't that funny? Microphone one is here, and microphone two is here, okay? And they're 1 mile apart, so I just kind of sketched this. And we're gonna always assume that it happens from the origin, okay? Microphone A receives the sound 2 seconds before microphone B. Now, I want you to think about what that means. Microphone A, okay, receives the sound 2 seconds before microphone B. They're going to both hear it, but this guy's a little bit delayed, right? So a little strange thing is this, okay? And I want you to know that this microphone, the sound is traveling in a hyperbolic path, okay? So what I mean by that is this. That it's traveling like this, okay? And so if you think about the hyperbola, it's traveling like this, okay? My drawing here is a little bit off. They should be equal distance apart, okay? Sorry about this, all right? So the sound travels like this, which means that this guy is gonna hit this hyperbola, and what happens? It goes to this guy here. So it's driving like, the sound is traveling this way. So it hits anywhere along this hyperbola, but you know that it's also going to hit back here, okay? And you know when it receives the sound 2 seconds before B, all that's really saying is, you guys, all that's really saying is that this distance minus this distance is 2A. Again, following the other example, we know a lot of things. That kind of constant, this 2A is a constant, and you remember that constant is actually the value of 2A. So that's what this kind of implies. Microphone A receives 2 seconds before microphone B. I want you to think about it. This guy receives it first, it travels here, but really that distance is 2A. Think about that, okay? So let's actually organize a little bit. Oh, they want to know, where did the explosion occur? Okay, and assume sound travels at 1100 feet per second. So first thing we're going to do, assume is at the center, make it easy, okay, is 0, 0, okay? Second thing is this, if it's 1 mile apart, and that's 5 to 8 feet, okay? So just keep that in mind. That means C, because this guy is at C, isn't this really our C? Because this is our hyperbolic path, right, sorry. This is our hyperbolic path, so that's our C. What's our C value? Our C is 1 mile over 2 because it's 1 mile apart. So our C is actually 5 to 80 divided by 2, which is 26440 feet. Makes sense? So our C, which is from here all the way to the first microphone, is 2640 feet. All right. Third thing that we can establish is that 2A is equal to 220. We can assume that because of this fact here. Because this distance, not this distance, this here, it traveled 2 seconds. This guy heard it 2 seconds before microphone B. Okay, so I want you to think about why this is true for the sound, okay? And it's 2A. And that 2A is 2200 feet because it's 2 seconds. And you know 1 second is 1100, so that's why it's 2200. All right. Now it's 2200. That means A must be 1100. Okay. Okay. Again, this is true because sound travels 1100 feet per second, and it traveled for 2 seconds, and that's why it's 2200. All right. Now it's coming together. Okay. So let's go 4. A squared plus B squared equals C squared. So we know that B squared is equal to 2640 C squared minus 1100 A squared. And B squared is 59600. Woo! Okay. So why are we doing all this? Because it's traveling, remember, this microphone sound is traveling along the hyperbolic path. Remember, it hits anywhere here and hits back here. Hits anywhere here, it hits back here too. So let's put that together. It's going to be x squared over 121,000 because 000 because that's our a squared minus y squared over 575,966, which is equal to 1, which tells us, watch, remember, microphone A receives the sound first. That means along this hyperbola, it's going to hit anywhere along the right branch first. And this shows that path, okay? I hope everything was okay, but please ask questions if you are unclear of anything, okay? Good luck!